Morning, everybody. We're starting chapter 11 today, and chapter 11 is about the periodic table and bonding. Obviously, we're doing the periodic table first, and there are three people who are important to know about when you're discussing the periodic table or learning anything about the history of the periodic table. The first person is an Italian chemist by the name of Cannizzaro. Not sure the spelling, but I think that's it. Cannizzaro was the first person to come up with a method to determine standard atomic masses. So we have standard atomic masses. Unless things are standardized, people can't compare one thing to another. I mean, that makes sense, right? So once we had a method to determine the mass of, say, sodium versus the mass of chlorine versus the mass of carbon, chemists could start talking about them. And one chemist who did was a Russian chemist by the name of Dmitry Mendeleev. Mendeleev's name is the name most associated with the periodic table, which we're just going to call PT or P table for right now. Okay, PT though. Mendeleev was kind of an odd duck. He liked to go to his lectures at the university dressed in costume, which probably didn't give the other scientists he knew the best impression of him, but what the hey. Anyway, back to Mendeleev. He used not only atomic masses, he used both physical and chemical properties, that's his properties, to try to arrange the elements in some semblance of order. It's my understanding that he did this using cards that he kind of glued up around his house based upon their properties and their masses, and he would periodically have an insight and move one card or move the other. I don't know if this is true or a not so urban legend, but anyway, he did come up with a basic periodic table, and you should have a copy of the periodic table in Cyrillic in your textbook. He had periods, or he had horizontal rows that we now know of as periods, and he had vertical columns that we call groups or families. Every period, you now know, is defined by the principal quantum number n, and elements in a particular group or family have similar chemical or physical properties. Mendeleev, as I said, probably wasn't that highly regarded at the time just because he was a little bit odd, but Mendeleev predicted three missing elements. One of those elements was between aluminum and germanium on the periodic table, Mendeleev's periodic table. He called that missing element eka-aluminum. What he called it isn't important, but what was important is he predicted the properties, the mass of eka-aluminum, both chemical and physical properties, the mass. Other chemists were intrigued by this. They attempted to find this missing element. They did find it. It is now known as gallium. He predicted two other missing elements, which were later found, and that gave a lot of credence or belief to Mendeleev's periodic table. Now, for the most part, he arranged elements from the lightest on the left-hand side to the heaviest on the right-hand side, and lightest to heaviest going from the top to the bottom. In a couple of cases, he did not do this. We now know that argon is way over here. It's a group 18 metal, or group 18 non-metal. It's a noble gas. It's very non-reactive. And immediately following argon, we have potassium, which is a very, very reactive alkali metal. Argon weighs more than potassium. Not by much, but it does weigh more. And Mendeleev realized that these two belonged in these positions and not flipped because of their properties. The fact that argon was a non-reactive gas, and potassium was a highly reactive metal, meant the potassium needed to be with the rest of the highly reactive metals. Anyway, one other guy that gives us a full picture of the periodic table was a British physicist by the name of Moseley. Moseley came up with a standard method for determining atomic number. Okay, remember, atomic number is the number of protons in an element. Our current periodic table is based upon atomic number. You have hydrogen here, and way over on the other side you have helium-2. So you've got hydrogen with atomic number 1, helium with atomic number 2, and then lithium and beryllium with atomic numbers 3 and 4. Then we go on over here to boron, carbon, nitrogen, oxygen, fluorine, neon. Hey, I did it. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way across to 18 down here. That's how our current periodic table is arranged. So what you guys are going to be doing today is making up your own periodic table. So after you've had a chance to look over the notes for today, we'll meet back, see if you have any questions, and then I'll show you the assignment for determining or for putting together your own periodic table. So see you back in the virtual classroom in about 10 minutes or so.